Assalamu alaikum everyone, hope you guys are doing well. So welcome back to another video in which we're going to be solving the Edexcel International A-Level Math Mechanics paper of January 2024. So let's start. This is the first question, which is about, well, we have a string, there's some tension, so it's about forces. Let's see what we have here. Figure 1 shows a small smooth ring threaded onto a light inextensible string. Alright. One end of the string is attached to a fixed point A on a horizontal ceiling, and the other end of the string is attached to a fixed point B on the ceiling. Okay, let's read the question further. A horizontal force of magnitude 2 Newton acts on the ring so that the ring rests in equilibrium. So that's very important at point C, vertically below B with the string taut. The line of action of the horizontal force and the string both lie in the same vertical plane. The angle that the string makes with the ceiling, where A is theta, where tan theta is equals to 3 upon 4. All right, this is what the question is talking about. The tension in the string is T newtons. The mass of the ring is m kg. Find the value of T. Okay, so before we do anything related to T, we know that tan theta is equals to 3 upon 4. We know that once we break down the forces, we will need sine theta and cos theta. So let's figure that out first. So if tan theta is equals to 3 upon 4, that means we're looking at a 90-degree triangle with the opposite side as 3 and the adjacent side as 4. So the opposite side is 3, the adjacent side is 4, which means the hypotenuse side is going to be 5. So that means sine theta is equals to opposite over hypotenuse, so that's going to be equal to 3 upon 5, and cos theta, which is equal to adjacent over hypotenuse, that's going to be equal to 4 upon 5. Okay, now what we're supposed to do in the first part is that we're supposed to find out the value of T. So let's mark all the forces here. So we have T acting away from the object, we have T here also acting away from the object, okay, and then there is the mass of the ring, which is m kg. Okay, so that means this is mg newtons, and what we're supposed to do is we're supposed to find out the value of T. So since it's in equilibrium, that means all the horizontal forces or the sum of all the horizontal forces will be equal to 0, or you can say forces acting on the right will be equal to forces acting on the left, and similarly all the forces acting upwards will be equal to all the forces acting downwards. So if you look at the left and the right forces, so there's only one force that's acting towards the right, and that will basically be the horizontal component of tension. Okay, so let's make a triangle over here. Let's complete this triangle, and with the help of this triangle we can see that the horizontal component will be equal to T, since this, by the way, will be equal to theta. Why? Because of alternating angles. So the horizontal component will be equal to T cos theta. Okay, and this is acting towards the left, and the only component that is acting in the opposite direction of this, the only force that's acting in the opposite direction of this force is the 2 Newton force. So that means these two must cancel out each other, or they must be equal to one another. Okay, so there are two ways of actually putting this. One is that we would take the rightwards direction as positive, and we say 2 newtons plus minus T cos theta Newton is equals to 0, or you can say simply right is equals to left. And remember, the reason why we're doing that is because the question says that it's in equilibrium. Okay, so T cos theta, force that's acting on the left, is equals to 2. What's cos theta? We figured that out to be 4 upon 5 is equals to 2. So now we can find out the value of T. 5 times 2 is 10, 10 upon 4, which is equal to 2.5 Newton. You can obviously write it as a fraction also if you want, but since it's a terminating decimal, there's no harm in writing it as a decimal as well. So we have the answer to the first part. Now let's have a look at the second part. The second part says find the value of M. So we've considered the forces acting horizontally, but we haven't considered the forces acting vertically. So let's find out the vertical component of tension, which would be equal to T sine theta, and then there's another force acting upwards, that's T. Okay, so T sine theta plus T, these are all the forces acting upwards, and their sum must be equal to the sum of all the forces acting downwards, and there's only one force that's acting downwards, and that's basically the weight of the ring. Is it a ring or what is it? Whatever it is, this is the sum of all the forces acting upwards will be equal to the sum of all the forces acting downwards. So T sine theta plus T is equals to mg. So T we just worked out to be 5 upon 2. Sine theta we worked out to be 3 upon 5 plus T once again, so that's 5 upon 2 is equals to mg. So we cross this out, 3 upon 2 is 1.5, 1.5 plus 2.5, what's that equal to? That's equal to 4, so 4 is equals to mg. Then using g as 9.8 meter per second square, we can find out the value of m, which turns out to be 0.408 kg. And there you go. That's the answer to part B and also the end of the very first question.